Hello, good morning to one and all. Today we are going to discuss the non-destructive testing. So comparing with non-destructive testing with the destructive, it is more useful for making to give very good quality as well as the inspection duration part. Regarding what are the non-destructive testing methods or testing inspection methods. Before that, destructive testings are like the UTM, tension test, all this one. So in this one, we are going to discuss the radiographic test and how we are going to produce the X-rays and gamma rays and the interaction with the matter. What is the safety aspects with regarding radiographic techniques? I mean, we are using the radiographic equipment. So introduction is going to be other terms of non-destructive testing is going to be named as called non-destructive examination, non-destructive inspection, and non-destructive evaluation. So by considering this, all the terms is related NDT. So that is called non-destructive technique. So we are going to be manufacturing good products. Before making to good products, one of the better thing is the quality wise. We need to become very important. So most of the companies we are going to be material support their services, goods to be produced. In that we need to give the testing. So testing is very the crucial part of the products as well as in services also. So when we are making to fulfill the standard quality by required by the customer, so automatically our company good name will come. So before making to release the product into the customer, we have to check thoroughly of all the specification with respect of dimensions of the product. So by using the NDT techniques, we can easy to identify the defects with respect to of different types of applications like welding, casting, all these pressure vessels we can make to test. So we have testing material can be classified into two types, that is destructive and non-destructive testing. So destructive testing is a we can make related mechanical testing. Here we are using testing with respect of what is the workpiece, that is the material concern, and properties that makes thermal, mechanical, electrical, all this we can make to analyzed. So by the end of the test, the workpiece will be distracted. That means the test workpiece of the whatever we are tested by using destructive, the assessment is not making to use further. That means it is going to be discarded. So it is not used for future work. So the end of the mechanical testing, the workpiece is going to be damaged. To overcome these failures, non-destructive testing or invented. So when we are making to give the non-destructive testing, why we require means one of the major point is in after completion of the testing with respect of destructive, the workpiece cannot use for further. So the damage of the workpiece we are not able to use for the process. Whereas to overcome this type of a failures, non-destructive testing are invented. So what are the some of the destructive testings are tensile, hardness, fatigue, impact, compression, bend. So we need to give the tensile test by elongation of the rod so that we can know the what is the tensile strength of the specimen. In the same way, hardness test we are going to be identify the material. Like the continuous impact loads is going to be used by fatigue and impact, we can make to test with the respective processor. So like that, we are making to give the process of the destructive. So by making the next is the non-destructive testing. Why? Because already we discussed that after the usage of the workpiece, we are making to fail that we are not using for the future purpose. So better we need to go NDT testing, which is going to be material to test without disturbing the process, so that we can make to give the non-destructive process in this component of the meeting, testing, evaluating, and assembling of the disconnectives. So without destroying the serviceability of the part of the system, we can make to test the completed part where we can use for the process. So NDT is an examination that is performed on an object of any type, size, shape, material. So by initial material also we can test. That is whatever the available of materials, type of materials like aluminum's material properties we need to study, and what was the size and shape. So it can make to any presence or discontinuity. So in presence of material, initial material also we need to identify whether the material is suitable for making to get product or not, whether any discontinuous are there or any characteristics beyond the material available of initial material. There will be some characteristics we need to identify. So difference between this destructive and non-destructive is, moreover, both are using for making to find out the defects, but here in destructive, finding the properties of material. In non-destructive, we are finding the defects. That means how much depth is there in the defect item and where it is going to be crack occurs, where in between the inner and out. So many defective parts we can analyze. So here non-destructive, not load is not applied on the material, whereas in destructive we need to apply directly on the material of the specimen. So we can make to no material damage in non-destructive test. This is one of the major advantages in comparing with the destructive. Whereas in destructive test, due to load application, material gets damaged. Here, no requirements of special equipments, whereas in destructive test, we need some special requirement. Suppose when you are conducting tensile test, that is universal testing mission, we require some setup required. Separate setup is required for making to elongation, breaking point. All this we need to calculate. We need some separate setups and making to give the details. So non-destructive is non-expensive, whereas in destructive it is expensive. In non-destructive we can get the less skill operate. We can make to operate, we can make to test, we can make to inspect with a semi-skilled, less skilled person also. Whereas in skill required in destructive testing. So these are the ultrasonic, eddy current testing, dye penetration, liquid penetration, radiography. These are the non-destructive testing missions. Whereas in destructive test, we can give the tensile compression hardness. So these are the differences between destructive and non-destructive. So what are the objectives of NDT, that is non-destructive testing? First is material sorting. What was the material is available and whether the material characteristics are effectively is suitable for making our product or not. So the material sorting we require, first point, and characterization and monitoring for process property. After making this, the thickness of the measurement. So initial material size, shape, and as well as final product, like after completion of the product, we can see the whether it is a defect detection or location of the process. So defect characterization. So we can make to identify the range of defects. Very important point here. What was the range? Whether the defect is going to be suitable to rework or reuse, or it is going to be the scrap, or defects can include like flaws. That means some errors which are making to give the flaws, such as in heat treatment cracks. Due to overheat treatment, suppose the temperature is going to be beyond the requirement of the material. Suppose the material require withstand the temperature only 250 degrees centigrade. Apart from that, we are making to any heat treatment. That means the cracks are there. So that cracks can make you use, we can identify with the help of NDT. So pores, fatty cracks, so we can make to grinding cracks. All these we are making to analyze with respect of NDT with ultrasonic radiograph testing, dye penetration testing, liquid penetration testing. All this one we can make to process. So NDT methods we are using visual inspection and liquid penetrate method, ultrasonic, radiograph, eddy current, magnetic particle testing, thermograph. So by seeing visual inspection, we cannot able to see the depth of the product defect. So better we need to go remaining NDT methods. In visual inspection, by seeing on top side, we can able to identify, but when we are making to see the depth of the defect item, we are not able to see the process. In this, there are visual inspection we can make to see the by seeing the with the respect of some equipment, liquid, magnetic particle testing, eddy current, ultrasonic testing, radiograph. These are the types of NDT we can make to process. So visual inspection, the capabilities are macroscopic. So what are the limitation here? Small errors are difficult to detect. So very by seeing visual inspection, we can able to see some normal range only. In that normal range, we have to identify. Beyond that, the errors, defects we are not able to identify. So for that, we can make to go to the microscope radiograph. Radiograph is also small defect detachable with respect of thickness of 2% where can radiation protection is required. That is the major disadvantages, or we can make to see the protection is required from radiation for who are going to test the components. And ultrasonic dye trace material with respect of this, whatever you are going to select the material in ultrasonic, that material is conductor of sound. So when sound is going to travel, then we can able to identify whether the product defective or not. So in this way, we are making to inspection the process. So in the NDT methods, they given the chemical processing industries, they given some requirements with respect of some standards, that is ASNT, ASMG, ASTM, all this we are making some standards they follow. So what is meant by visual inspection? So visual inspection is the simplest, fast and most widely used, where the examination of material component with respect of with using light and eyes. So where by using visual inspection, by seeing common human eyes, we can able to process. But in visual inspection, when we are often involved, there will be shaking, listening, feeling, and sometimes even smelling of the component can be inspected due to overwhelming, due to overheating. Then that time the smell will get the visual inspection by seeing that that product is going to be somewhat beyond the temperatures is going to be heated. So by smelling that, we can say that the component is going to be that. And the same way we can make to digital detector and computer technology. So we, this is known as a mission vision. So in this way, we can make to see the visual mission vision and characteristics depicted. So here to detect surface such as scratches, cracks, color, and any corrosion. So whatever the material is going to be due to some chemical treatment, somewhat like that, we can say that the corrosion can make to give. So what is the principle is visual testing with illumination of test surface with the proper eyesight. So when we are going to, who are going to test or the component, that should person should make to give the proper eyesight, because by seeing visual only whether the assessment is going to be within the limits or not is going to be observed. So the test assessment is going to be observed and examined. So we required by seeing visual, we required such as mirrors, magnifying glasses for making to magnification from deep to deep, and microscopes and video cameras which can be employed. So by seeing visually, the person should make to give high sight proper by using accessories like optical mirrors, magnifying glasses, microscopes, videos, computers, and all the systems should be employed. So what are the advantages of visual inspection? Simple and easy to use, relatively inexpensive, and testing which in service permanent records are available. But limitations are, these are the high resolution is weak, definitely, then will be the errors are not able to identify during the depth. So by seeing visually on the some button point we can able to identify, but due to resolution is weak, then he is not able to scan, we are not able to visualize the in-depth of the component. So the test depends is going to be the results. Whereas the applications is going to be simple by seeing alignment and shape of the component, evidence of the leaking, internal side effects, checking of the surface condition of the component we can make to use. So these are the accessories which is required for making to give the visual inspection, microscope, videoscope, microscope of all these glasses. Next important one is the non-destructive testing method was radiographic testing. So this is also very important NDT techniques. So before that, we need to give some technical terms. What is meant by radiation? So radiation is normally we are using energy that travels with through space or in matter. So normally cell towers, radiations, all these radiations are like the energy is going to be travel through space, where we can make to give the radiation effect. In that ionization means which is formation of ions, that is called charged atoms or molecules when interacting with matter. This can make to biological damage with respect of the cells. So with the proper radiation we need some x-rays, gamma rays, neutron, cosmic rays, all this one. But in your silvers we are making to concentrated on x-rays and gamma rays, so they contain with electrons with respect of atoms and molecule, which can make to interact with the process. So this is the ionization. Non-ionization, which is not making to, does not eject the electrons from the atoms, which they interact, then they cannot cause ionization. So we are making the radio frequency with respect of non-ionization. So it is a X-rays and gamma rays only we are making to use for view of internal structure of the component. In the petrochemical industry, radiograph testing we are using to inspect machineries such as very high pressure vessels and valves, which can make to detect the flaws. So this is the where we can make to useful with the radiograph testing. So radiograph testing is useful to weld repairs. Comparing with other NDT techniques has several advantages. What are this? Variety of materials which can make to analyze. So it is making to restricted some materials in some NDT techniques, but here it is can be used on variety materials. So radiography is used in very range applications, medicine, engineering, security concern, all this. So this is the one of the most important and widely used methods in order to give the major disadvantages of health risk in the process. Next one is the electromagnetic radiation. So it is a no mass, it is unaffected by the electrical magnetic fields. So electromagnetic radiation, which is going to be very propagate through matter, it travels, so it can make to use the maximum speed is going to be like this. So radiograph testing mostly used in detection of internal defects, porosity and void. So when you are providing castings like that, the defects is going to be how much the slag holes can make to give the porosity with the proper orientation of X-ray beam, which planar defects can be detected with the radiograph. And moreover, it is suitable for detecting changes in material composition, thickness hidden from the assembled part. So we all of know that one assembly is consist of remaining a sub 10 5 or 10 sub assembles. So when we are assembling one part, there will be the some disassemble remaining sub assemble components, we need to give the very good process. Suppose in 10 assemble, one assemble, there will be 10 sub assembles. In 10 sub assembles, there will be any one defect is there, total assemble component is going to be wastage. So on that defect component hidden from view in assembled part. So we are not able to, by using a radiograph testing, the hidden point of assembled point of view low, we can make to identify the defect. So the before making to actual setup of X-ray ultrasonic radiation, we need some requirements, that is nature of penetration like that. So up to here we can stop. Next class we can discuss the remaining procedure for the process of the setup.